Hey guys, my name is Tushar Khainar. I'm the creator of DrutaVahan. In this video, I'll show you how to use DrutaVahan to bootstrap a project from existing blueprints and deploy the generated app. And later, I will walk through Druta configuration and code snippets to understand how Vahan application looks like. So let's create a project using a blueprint named ping pong, and we'll use a command called blueprint gen. Okay, so it asks you for some information. So we have app 4 io.druta 4 client 4. So the project is created. So if you notice, this project has Gradle integrated into it. Let's build up a deployment package. So before that, we'll have to set up a Vahan home path, which is basically picked up by the Gradle to set up the class path. So build zip will create a zip file. So once the package is ready, we will start a delegate process, which is a accompanied process for deployer, and deploy the package using DrutaVahan. So let's start Gradle. Okay, so now each developer basically needs the Druta ID files, which are basically registration files for Druta. So let's copy from another project for this video. So here you will say it will upload the distribution file, it will create a new stack using a generated template. Now the template is created by combining all services deployed descriptors. So till the stack is deployed, let's see the Vahan configuration file, how it looks, and we'll also go through the service definition. So here is a deployment package defined, and we have something called handlers, and you have something called services. Now services section is basically where you will declare all your services. Here the RPC and the implementation class. So we'll go through the implementation class later, but the important piece here is something called app4, the handler name. So this service is basically tied to this handler, which is configured to have this much memory and the timeout, and this will basically run this lambda. So let's go through the deployment script service definition. So the services are declared using something called protobuf files. So these are the lifecycle methods that are required to that each service should have, and these are the methods that you want to expose over the to all the clients. It accepts a request and response, so which is a pretty much standard protobuf stuff. So now let's go back to the stack. So now here you see the client template generated, and it has been uploaded, and the stack is getting created. So stack is created, and you will see these are different resources it created and the output. Deployer also takes care of deploying the saving all the stack output to a local file called AWS outputs.json. So here the endpoint is readily available to you. So now let's go to the AWS console. This is a new stack created. Okay, these are the resources. Okay. Let's have a look at the Lambda created. So Lambda is actually passed on all the required information, which class to invoke. It also inherits all the properties that you pass in the configuration. So so if you observe, this Lambda is basically corresponds to one particular handler declared in the configuration file. You can have many handlers, each having different configuration and a different set of services attached to it. This way you can allocate more resources to a heavyweight service. You can even have 5 different handlers for 5 different services. Okay, so now the backend is deployed. Let's generate a client and use it to ping our newly deployed cloud backend. So let's generate a Java client first. Okay, the class is generated. So if you see, this is a very simple class which is extending a base client, and for ping method it is passing out the service name and method name and response class. So since all the services are strictly type, type inference makes it easy to generate a fully compliant class, and most of the communication and interfaces is taken care by the base client, which is provided out of the box to you. So the protocol is completely language agnostic, and in addition to Java, we also provide JavaScript clients and Dart clients. So Dart client can be used to develop cross-platform mobile applications. So now let's uncomment the references to the client which was absent earlier. So this is the sample apps actually that has the main method is commented, because then so that we can compile and deploy the app. So if you see this deploy output reader, it is reading the AWS outputs JSON. So nothing is hard coded, and it will get the endpoint and use the endpoint to call the service and basically output the date and name. So let's do that. What happened? It didn't send it. So here you have the name passed and server date, which is in UTC. So if you see, within 5 minutes we have created a Java project, deployed to the cloud, ran a client to invoke the service. So here the project is very simple, but imagine if you have 5-6 different services, each having different methods and each talking to different cloud resources, right? So, but irrespective of the complexity of such project or this simple ping pong app, the process of deploying and developing the app will remains the same if you use DrutaVahan. So this video demonstrates the value proposition that DrutaVahan has. In the next video, I'll cover the mobile as a backend blueprint and also the static website blueprint, which involve more cloud resources like DynamoDB, Cognito, and CloudFront. So do give a try out to DrutaVahan, download and start deploying your services and deploy it in within an hour. Thanks for watching the video.